let's simplify this product of monomials. So we have 7u to the negative 5 times u multiplied by 7w to the negative 5th v to the negative 2 v squared multiplied by 2w cubed. Now as a first step here, I like to underline or acknowledge the constants. We have or the numbers in other words. We have a 7 and a 7 and a 2. And so since we're multiplying these all together, 7 times 7 is 49. 49 times 2 is 98. So I'm just going to write a 98 here, and that comes from all the numbers being multiplied together. Then, in the following step, I like to look for common variables, variables that have the same value. So here we have a u to the negative 5, and technically, although it's not written in, we have a u to the first power. So there are no other u's in this problem, so u to the negative 5 times u to the first power means to add exponents together, and those pieces are going to come together to become a u to the power of negative 4, because we add exponents according to exponent rules. Next, let's take the v's. So with the v's, we have a v to the negative 2 and a v to the power of 2. Notice that v to the negative 2, v to the 2 will add together, or the exponents will add together to give us 0. So we'll end up getting v to the power of 0. And then finally, as our last piece here, we have the w's, and see there's a w here and a w here. So we'd end up getting w to the, let's see, the powers are negative 5 and 3, and negative 5 plus 3 is equal to negative 2. So we get v to the negative 2. So the last answer, the final answer to this particular problem would be to say we have 98, we have a u to the negative 4, v to the 0 is actually equal to 1 because anything to the power of 0 is 1, and then w to the negative 2. Now for most intents and purposes we like to have this simplified in the sense that we don't like negative exponents in a final answer in an algebra or pre-calculus course. So the 98 is just the 98, so I'll write it here. The u is being raised to the negative 4, so I'm going to move it down to the denominator and make it a u to the power of 4 in the denominator. And the w is being raised to negative 2, so I'm going to write a w squared in the denominator. And this would be rewriting the expression with no negative exponents if we wanted to have all the exponents be positive. Okay, so why don't you take a shot, pause the video, and see if you can do this particular problem. Assuming you took a moment out here and tried it on your own, let's try to do it together just if we can see if you got the right answer. So again, following the same process as before, I'm going to underline my number parts and see that I have a 4 times a 3 times a 2, and a 4 times 3 times 2 is 12 times 2, that's 24. So I will write 24 right here. Variable, let's go with the first variable I see, even though it's not the first numerical variable. I see a y to the 6th, and I see a y to the negative 6th. And so I'm going to add together those exponents, 6 plus negative 6, and that of course yields 0. So I get a y to the power of 0. The next variable I see is a v, so there's a v, and there's a v. So it looks like I'm getting the exponents on v. Here there's no exponent written in, so I understand that to be a 1. So I have a 1 plus negative 9, which of course would be negative 8. So we get a v to the power of negative 8. And then finally, for the last variable, which looks like an x to the x variable, we have 7 and negative 7, and of course 7 plus negative 7 is also 0, so we're going to end up getting an x to the 0. So your final answer would be 24, y to the 0 is just 1, v to the negative 8, x to the 0 is just 1. So this would be one possible correct answer, and if you were told not to write it with negative exponents, you would write this as 24 over v to the power of 8, because the negative exponent moves things down to the denominator.